equilateral triangle, 0.5 meter size, with charges at the corners of those. This is the same as the fourth problem. The only change is you do it in field. The field is still a vector. They are the same thing, basically. Therefore, equilateral triangle, here is positive 5 mu c. Right here you have negative 10 mu c. And here you have negative 10 mu c.
Why did you divide it? Oh, to do the halfway.
Therefore,
Yeah, I cut the whole thing. Just cut the whole.
Did you do 60? Oh, you just
okay, center.
He said he could.
Center is right here.
He says it's fine till the test. Then I'll be like, oh, awesome. But it's just.
Now you need to calculate something.
Oh.
Yeah.
Side, assume side is A. You want the field at this location, right?
Mm-hmm.
Okay, so to make it clear, I draw a picture at somewhere else.
I don't think the geometric terms are enough.
Alright, I pick up the middle point here and put it down here. Alright, what's the direction of field from this one at this location? Direction.
That one's negative.
To it.
This is negative. The field here will go to
The right. Down.
this way along this line, right? Because if you put a positive test charge, they attract. Therefore, you have a field over here. And how about this one?
Same.
The field at this location from this one
Same.
will go this direction, right?
Yes.
Okay, will go this direction. How about the third one? Right here is positive. What's the field generated here?
Positive.
So it's going to go
Going down or going up?
Down.
Down.
Down. Why down?
Positive test charge.
Yeah, positive test charge, they push each other. Therefore, you have another one goes this direction. Are those three vectors have the same magnitude? Uh-huh.
No.
For these
Yeah,
two,
well, they're
yes,
going-
this one
Those two,
equals this in magnitude.
Yes.
But this one is not.
Right.
This is only 5, right?
Yeah.
Yes.
You just add these three together. For example, this is E1, this is E2, this is E.
You're going to
Three.
see. I get the concept. I'm just blowing it. That's all.
It's too hard to know how far he wants you to go. Yeah, I know. 1, E2, E3.
Therefore, you need a coordinate
But it's
system.
like, do you want us to write? Just
This is Y, this is X. Then you are ready to play the game, right? This is equilateral triangle. What's this angle?
I use theta.
That's smart.
Yeah, theta is
I
fine.
really did. I did this a whole one.
But you have to tell people the exact angle. Because this is the equilateral triangle.
It's
It's a 45. Oh, it's 60 on
Think
the
about
side, so
it.
it's 30.
Think about it.
It's 30 on
Is
the
that
right
not a
each
right
way.
angle
You see,
between?
if you draw a line here, that's x-axis, right?
Yeah.
So the total angle here is 120, right?
Mm-hmm.
But this is 90. 120 minus 90 equals what?
30.
30. Therefore, this is 30 degree. This is also 30 degree, right?
Yeah.
Okay. Therefore, everything becomes very clear.
Okay.
All right. The total field E will equal to E1 plus E2 plus E3. All right. Just expand it. E1 is this one. It has two components, right? Y is here. Y is here.
Sorry.
Oh, okay. How to calculate the x component here? The magnitude E1 times cosine 30 degree, right?
Yeah.
That's x component. What's the y component?
Is negative
Magnitude times what?
sine.
sine, but it's negative.
Yeah.
E1 times sine 30 degree J.
Uh-huh.
And the whole thing here is only E1, right?
Yes.
Yeah.
Then you plus E2.
Yes.
E2, E1, they have a symmetry here, right?
Uh-huh.
Yeah.
Therefore, the similar. But E2, x component is negative.
Correct.
And E2 cosine 30 degree I. The other one is
It's
negative,
also
positive.
Negative.
Oh, also negative.
Uh-huh.
E2 sine 30 degree J.
Mhm.
That's the second one, right?
Yes.
And the third one, E3, what is it?
0. I.
X component is 0. You see, it's vertically down, therefore in x direction it's 0. Only y component, there's no angle involved. The magnitude E3 times J, that's it.
Wait, where do you
Just E3 times J.
And at the side of this deriving, you have to do some additional work. Right here, E1 and E2, they are equal in magnitude, right?
Why wouldn't that be a negative E3J?
Oh,
That's fine.
you're right.
And you don't have to use sine? I kept sine of my angles even though I knew it was going to
Okay.
work.
Yeah, you
Sine
can.
90 is
There's
fine.
always one.
Cosine 90 is fine also.
Yeah.
But what's the value of cosine 90?
It's for them it's 0.
Cosine 90 is 0, right? Sine 90 is 1.
Yes, and we already know it's 0.
Okay,
I'm
if
doing
you-
sine, so
Yeah, if you have to use them right here, it'll become what?
negative EQ1 sine.
It's E3 times
Sine.
cosine 90 degree I
Yeah. It's 0.
minus E3 times
Yeah.
sine 90 degree J.
Just doing J.
Am I right?
Yeah. But that would be 0.
So equals negative.
The x
93.
positive negative doesn't matter
Yeah.
because this guy is 0.
Right.
Yeah.
0 multiply anything is 0. That's fine. Well, this is troublesome, right? It's obvious this vector is going down, negative y direction, no x components. So the simplest way is that just write it down. Negative E3 I. Oh, I'm sorry, J. That's it. That's the easiest way. And before you write down the next step, carry on this one. It equals k times what? Micro, mu 10 to the negative
10, 26.
6.
Okay.
And multiply k is negative 5, right? Divided by the distance squared. And now you have a problem. The side is A, it's given 0.5 meters, right?
Yes.
So what's this distance? How can you calculate this?
Divide by 2.
See? You have a right triangle, right? Right here.
Yeah, it's
Well, 0.25.
You know this is half A, right?
yes.
Mhm.
And what's this angle?
60.
30.
No,
30.
30.
30.
Okay. You know this is 30 degrees, this is half A. Can you calculate this?
Mhm.
Which function you need?
Tangent.
Okay.
Oh,
Cosine.
you get me so frustrated.
Cosine. Okay, you see? Cosine
That's right.
30 degree equals what? Equals half A
Mhm.
divided by this distance R. Therefore, solve this for R. R equals what?
1/2 A over cosine 30.
Right?
Could you do, I did my R as 0.25 over cosine theta.
Okay, if you want 0.5 over here, that's fine. Keep going. 0.5 here is 1/2, right? The Is this 1/2?
Yeah.
Okay.
Over
2 cosine 30 degrees. Therefore, you have 1/4 times cosine 30 degrees, right?
Yeah.
Or if you want, now we know the cosine 30 degree, it is what?
I didn't go that far. I did cosine theta.
Cosine 30 degrees is square root of 3/2. Therefore, you got a very beautiful one, huh? Therefore, you got 1/2 square root of 3. That's r. And you put it over here, square. After square is what? Right? Okay, therefore finally you have 1.2 times 10 to the negative 4 k. That's E1 or E2. B equals this value. Okay, therefore what is E3? E3 is k times the source is 5. It's no longer 10. Therefore it's 5 times 10 to the negative 6 divided by, is the distance the same as this? Yes, you see this part, they are the same thing. If you already calculate r equals this, therefore square it, it becomes 1/12 again. Therefore this one will be 6.0 times 10 to the negative 5 times k. That's E3. Then you can put them in here, right? So E1 cosine 30 degree blah blah blah. Finally you got something like that. Oh, you can do it. Just merge these three terms, these two terms together, and merge these three terms together, right? And you can also figure out cosine. Right here I can tell you again, cosine 30 degree is this. Sine 30 degree is what? It's 1/2. And you can put in all the numbers here. You got the final solution. The only value you don't touch is the constant k. Just keep it. Because this number is not a good number, huh?
I have a question. So like when I was doing it, I didn't plug in the values for Q. Do you want us to go ahead
Oh,
and
it's
plug
fine. If you don't want to calculate the values, you just assume the charge. For example, this is 10, this is 5, right? If you assume this is Q, what's this?
Q?
Negative 2Q, right? This is what? Negative 2Q. Therefore, you don't have to. In the exam, if you solve the problem by using characters, then you're welcome to do so. I have no problem at all, and I appreciate that very much.